Hello, and welcome to today's webinar, Data Capture for GeoIntelligence, brought to you by GPS World Geospatial Solutions and our sponsor, Navcom. I'm Bethany Chambers from North Coast Media, publisher of GPS World Magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. The recording will be available 2 weeks from today on our websites, gpsworld.com/webinars and geospatial-solutions.com/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. Please notice at the lower left-hand corner of your console that there is a Submit button. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be answered in an upcoming issue of GPS World Magazine or in one of our e-newsletters. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Joelle Harms or I will personally assist you. Now I'd like to turn today's event over to our moderator, GeoIntelligence Insider Newsletter Editor, Art Kalinsky.
Hey, thank you, Bethany. And I'm going to be brief and get right to the program. But first, it was like 90 years ago that we started collecting data by sticking cameras out the cockpit of biplanes. And we've come a long way in 90 years. And in fact, this slide that I'm bringing up is from NCIS, a TV program. And the reason I bring it up is that the producer of that program insists on having real technology, not science fiction like James Bond. And so when I was with Pictometry and working with Lockheed Martin, they came to us and they wanted to show real technology rather than fantasy stuff. And so here is a picture of LL Cool J operating Lockheed Martin's touchscreen analysis system with 3D models from PLW that were created from Pictometry imagery. And like I say, it's not often you get a chance to put LL Cool J in the same sentence with GIS. But anyway, speaking of Pictometry, we have with us the actual inventor of Pictometry, John Ciampa, who worked extensively with Rochester Institute of Technology and now also works with Florida International University. I guess you got tired of the cold weather in Rochester. Is that right, John?
That's right.
So with that, I'm going to turn it over to John, and he's going to tell you about his technology. Thank you, John.
Thank you, Art. Let's see now. I'm going to push next. Get my ugly mug off. No, not happening. Wait a minute. Sorry. There we go. Sorry about the slides. Having a little difficulty. The slides are backing up on me for some reason instead of going forward. Let me try one more time.
I've got it here. Go ahead.
Audience, I got it. All right. So, Alta stands for Autonomous Lighter Than Air Systems, and what we were trying to do is figure out a low-cost, low-altitude way to have oblique imagery geocoded, instantly viewable on the Internet. We got help from National Science Foundation, FIU, RIT, Verizon is a partner, and our joint partner is Terrafly. So we now have developed a smart balloon. And if I click next, the smart balloon is controlled by an iPad app that we developed, and it's free in the App Store. The SkyPad controls the balloon look angles and the balloon altitude by spilling lift gas. Sorry, guys. I'm messing up show. The point of Alta is to kind of detail and footnote the world of existing available georeferenced imagery. Alta, of course, since it's lower, is 1 centimeter per pixel, and that's unprecedented resolution in the industry at the moment. And the cost, since the platform is a balloon, you can guess that the costs are much less than aircraft platforms. So low cost means frequent updates, and low altitude means the error lever on geo data is shorter, therefore the error is smaller, and also the resolution is better. This is an animation that's not working in the slide. Sorry about that. But there's my old love pictometry on the left, and that happens to be a ballpark. So the Bing imagery is pictometry on the left with, I think, 3 or 4 inches resolution per pixel. And on the right is Alta, and what you're not seeing is the Alta portion zooms in so you can read the number on the back of the chair of the stadium seat. The other good news is the Alta operator doesn't need to be a pilot, doesn't need a plane, doesn't need a working airstrip to take off from, can get to the site by bike, car, on foot. The air platforms launched in 3 or 4 minutes, and we trained college students in about 45 minutes. They were soloing. So the good news is that Alta operators can be just about anyone. This slide makes no point at all, but in the animation you're missing, we're showing that available technologies are expensive to update. So the 2 areas you're looking at show a blank field, and then what you're not seeing is the Alta image then goes exactly on the footprint where there was once a dump, and there are now 2 glorious buildings that you would not see with current imagery. This is an update we did for a college campus. One of the applications is we can monitor construction, and we have time sequence, obviously. Every shot's time stamped, so the construction from day 1 to closing, we can monitor as built, as designed platforms. And you're not seeing the animation again, sorry, but those guys are standing kind of in the middle of the shot, and the zoom that you see in the right corner shows whether they're wearing their safety belts or not. This is a tomato plantation we did, and again, you're not seeing the animation, but the zoom is from a row to a tomato, and you see the tomato in the right. Agriculture has enormous applications for us. We have visual cameras, we have multispectral cameras, and the multispectral cameras have some application in agriculture. This is a town we did called Sweetwater, Florida, and again the animation is there's a little fountain by the red car, and the zoom is onto that fountain, and it shows up in the right. We can actually do analytics and count the tiles on that roof. You can see in the corner of the zoom the lines between the tiles. This simply shows shoots that we've done for insurers, lenders, appraisers. The technology is patented. One of our exciting applications is event monitoring, because I used to be a criminal lawyer, believe it or not, before technology came into my life. But we here have a citizen or a million eyes watching an event, and if the citizen monitor sees an event, that appears to be suspicious. There can be any number of balloons at this. This could be Boston Marathon, could be any event. But the suspicious circumstance can be relayed to the police, okay, on scene. That is equivalent to a citizen calling a policeman, which gives him probable cause to go to the person and say, what is that you just stuck in your backpack or what have you. Anyway, event monitoring has the following applications over standard AUVs. We are a silent sentinel. We can stay up overnight all day. We have a night vision camera, a day vision camera. We can show you 1,000 feet away on a near screen. We can send some imagery right directly to the internet for an off-scene commander. So we can have on-scene and off-scene monitoring, and again, the balloon is unobtrusive, very small. Most people don't even see it. And the events we've monitored, people think it's a festive item. It never occurs to anyone that it's a spy. But anyway, it isn't, actually. It's just looking. Interesting story, when I showed this at a federal agency, they said, oh, my God, Big Brother's watching. I said, no, lots of little brothers are watching, you know. So that makes it totally legal. Again, you can see that we're up over 60 meters, and we can zoom in and tell you what kind of shoes that girl is wearing. We're very fortunate to have been honored on the cover of the NSF's Report of Technology Breakthroughs to Congress, and we thank NSF for their help and this honor. And I'm done, so I'm going to turn it over to Art, and I understand there will be a question period after, and I'll be happy to take questions at that time.
Yep. Thank you, John. In fact, we already have a question on that, and we'll cover that in the question and answer session. Next person up is Ted Ralston. And Ted, now Ted, you're in Hawaii right now, aren't you?
Actually, I live in Hawaii, but I'm in California at a field exercise up at Camp Roberts.
Oh, okay. I'm very familiar with that interesting place. But Ted is going to show us how far the technology has come. UAVs are becoming ubiquitous, but they're still very expensive, and Ted has taken it to the next level. So with that, I'll turn it over to Ted.
Okay, thank you very much, Art. What I'm going to talk about is sort of an ad hoc, almost organized effort that started to occur in November as a consequence of Hurricane Yolanda. What had occurred is one of our executives from Cal State Long Beach was rolling through the Philippines, taking a look at the marginalized areas in terms of disaster recovery efforts. And another colleague who's from one of the NGOs both observed that we really needed to coordinate better the NGO activities in response because there was no common operating picture, there was no coordination mechanism, so there was perhaps an unoptimized flow of resources and people in and out of the areas. And I'm working with a small quadrotor that's basically derived out of TAC Ops systems, just a little £1.5 actually extendable UAV that's used by Spec Ops for looking ahead and behind as they're maneuvering. And these guys said, hey, why don't you bring that helicopter out here, let's get a camera on it, and let's start getting some pictures in 15 minutes that everybody can look at and realize what the situation is and can better self-coordinate, self-organize, and let's get the job done. So one thing led to the other, and we started with a consumer-level helicopter, just a basically model airplane hobby shop type helicopter, because we were told that you got to be very careful to not make these systems look military, make them look really comfortable and easy and non-threatening. So that's what we started with, a helicopter to get invited in by the host country, Philippines, of course. And that was extremely effective. What we realized is that very, very low cost capability becomes expendable. expendable in the sense that you don't want to just throw it away, but if you were to lose it, the day's not over. You can get a spare. You can have 10 spares. So in thinking about that more, we realized that there's the consumer-level technology now in UAV form factor is benefiting from the work in cell phones, robotics, radio-controlled airplane, the miniaturized sensors, highly reliable systems based on precision manufacture. And a really important one is the crowdsourcing of operating software for these UAVs. There's a lot of people retired out of aerospace who keep working on flight management systems, inertial measurement systems in their retirement. So the capability to make these systems work is very high level on the aerospace food chain and very reliable. And then the analytics, taking the results by either true color or by cell phone spectrum, whatever you want to sense, can be converted to analytical products, again, by crowdsourced software. So high capability, high reliability, very low cost becomes a whole new way to think about these kind of systems, and expendability is the theme that has come up. You have acceptable risk, and that acceptable risk really encourages widespread operational use. Whereas with the more expensive systems, you may be a little bit held back in certain circumstances. So this led us to the realization that we could enable the lowest echelon unit, we'll call it 2 guys in a truck, for lack of anything better, in a very man-portable way to generate the information they need to operate their unit in a truck in a 15-minute time period in, say, a 500-meter radius around them. So that's what this notion of expendable UAV, XUAV, has come to, and we keep pushing it. We've had 4 deployments to the Philippines so far. I'll show you this next slide. Some of the pictures that kind of validated what we're talking about here. The upper left is just a picture over a village in the Philippines, a single shot, and that was extremely useful for people who are counting blue tarps and trying to understand where the aid is going. The next picture over shows one of the unexpected values here, and that's that these low-cost, non-threatening systems are really interesting to the schools, the hospitals, the sports arenas and such, and their participants. In this case, a school class. We did the imagery over their school, which is damaged, and they enjoyed that a lot. There's a few other examples here of natural resource management and fire observation, all done in this very low-cost 15-minute cycle of collection. The lower picture is done from a also expendable system. This is an airplane configuration as opposed to a quadrotor, but this is Tacloban's waterfront, and if you were to zoom inward, this is down about 2-centimeter resolution. So you can pick up things that you can't otherwise pick up from the ground. So this is where the capability is headed, and it is able to really empower the local agencies in a way that they perhaps haven't been empowered before. So let me show you the next picture here. This was done about a month ago at Joint Forces Headquarters in the Philippines, doing a demonstration of urban search and rescue. This structure is a burned out, probably 10,000 square meter building structure. And just as a demonstration, this was a 5-minute flight on a small quadrotor, 75 feet altitude, making 2 passes. The camera was set at 30 oblique, and the imagery processing was about 20 minutes to generate this 3-dimensional rendering. And of course, I can't show it here on the fixed slide, but you can zoom around, you can fly through this thing, look upside down, look in it, look outside it, and you can plan your urban search and rescue operation based on the current information that's no more than 15 minutes old. So that's just an example of the capability and how it has matured and how useful it is. So if you think of the ecosystem, which is more than just the UAV itself or the sensors, we really need to think backwards from the analytic decision support products that are available now at this very low level unit operation. available to responders, tactical operations people, and, of course, flowing uphill to the commanders. So the analytic products are coming out of the analytic software. The sensors in the, say, half-pound category are becoming very capable. We can do streaming video, which is interesting to lots of people, high-resolution stills to generate photo mosaics. We can get reflective IR. We can get thermal IR, atmospheric sensing, gamma radiation, cell phone network, spectral strength. Just yesterday we did a demonstration out here at Camp Roberts of a cell phone mesh network replacement flying a little half-pound payload on a UAV. So pushing ahead here, there's just some other, sorry about that. This is a sports arena, and this was used to observe the roof damage in the sports arena and understand how to get where to put the new materials coming in to fix the roof. That was a assembly site, and so I just have some more pictures here to show what the technology looks like. This is the smallest of the systems we've used. This is a TACOP system called Instant Eye, which is available. It's a commercially available system now. It's good for about a 3/4 pound payload, about 30 minutes on a battery. This is, and it's expendable. This is expendable. This is basically a large RC airplane here that's got about a 2-pound payload capability. Obviously, you can see it's made of foam plastic, so it's quite expendable, but quite capable. Autopilots, full mission planning, and all the technology you expect out of aerospace. Good example here of the kind of interest and attention you get from the people who come around. So we sort of empower the locals, not only in capability, but also interesting them in STEM and how to go forward, improving their own condition. This picture I really like. A little bit of technology goes a long way, and getting these kids interested in what we're doing, especially when you're looking at their own school or their own village, it was just heart-warming. And the last picture I'll show you is this one, which is something interesting. We were at first, when the 3 universities went in, by the way, the universities are Cal State Long Beach, University of Hawaii, and Ateneo de Manila in Manila. At first, we were kind of held at arm's length saying, I'm not sure we want these UAV things in here. But one thing turned to the other. We were able to generate this from a host country request for minimum capability, then more capability, and finally, at the end of the deployment, this is at the Officers Club in Manila, and we were treated to a very high recognition and the value that has stemmed from this. So where this is going right now is continuing to evolve the various kinds of payloads and the various sensors and the software that can be made available at extremely low cost to the world that needs it, which is, again, the lowest level unit, 2 guys in a truck. Empower them, generate leaves behind, and that is the population gets better rather than taking the expeditionary approach, which is how we normally think about these things. And make these systems locally customizable because the locals know best what they need. They understand the most important factors, and so we can optimize on those most important factors by empowering them at the local level. And so that's where we are, and we're continuing along. This is done totally ad hoc, almost organized. We just do it day in, day out, and moving forward. And
good. Thank you very much, Ted. We'll have some questions at the end here. Our next speaker, Paul Smith. Paul is with a company called Cyclomedia, and I was first exposed to that technology several months ago. And in a nutshell, they kind of do at a ground level what pictometry has been doing from the air. They create metric images and quite efficiently and quite accurately. And with that, I'm going to turn it over to Paul so he can explain the technology.
Thanks, Art. Hello, everyone. I'm going to talk briefly about what we call precision street-level imagery or precision panoramic imagery. And I'll kind of give you some of the basis points and sort of the technology of how that works. Cyclomedia started as a research project from the University of Delft in the Netherlands in 1980, and really we were, sort of for about the first 15 years or so, more or less in an R&D mode. We really went what I would consider more commercially viable in the early 2000 time period. The company actually started with analog techniques, and let me see. Is everyone seeing my presentation? There we go.
I think there's some issue with the forwarding. I've been forwarding the slides, but try pushing next and see if it works.
Okay, don't push. Let me push. Okay. Okay, so it's a patented technology. Started in Europe, as you know, from Netherlands, and we launched in the United States last year. All right. And the primary segments for our product are really around taxation, looking at property, building inspection, building condition, transportation, obviously, because we're along the roads, and then associated infrastructure, that's visible, within sort of 150 meters of the roads. So that sort of sets the basis point. I'll talk a little bit how we extend that into other areas as well at the end. Just a quick little visual of our company history. Again, I kind of said we started sort of in an analog fashion. That's sort of where the cyclo part of our company's name comes from, because we literally spun around film in a panoramic way and perfected that technique, obviously, over the last 30 years. And so the way that we position our product is we target it towards what we call sort of the asset management grade or GIS grade. For objects and features you're trying to recognize in a sort of a 10 to 50 centimeter, sort of a 6-inch to 18-inch range. Okay, I'm not sure. Art, you want to sort of take care of the slides and the way they're moving?
Yeah, which slide do you need to be on now?
I'm hitting advance, and okay, I just pressed, it doesn't seem to be, okay, right there it says GIS grade, focus of the products and services. And then go ahead and, I advanced to the next slide. And now I'm talking about basically our content and our viewer. And then it's changing. Now it's changing right now, and I have no idea why. So if someone...
Yeah, I just forwarded it for you.
Okay. Okay, next slide. Art, I'm going to have you do the slides.
There we go.
Yeah. Next slide. There we go. So we basically break our offering into the content, which we call cycloramas, which is our 360-degree panos, and then our viewing software to consume those. And that viewing software runs as a web browser app, a flash app, basically, as well as inside of various sort of desktop products. And in particular, in the United States, we focus on the Esri products at ArcGIS. Okay, next slide. So, and through that also, we have hosting options. Obviously, it's in the cloud, but we also provide it as an on-site server solution, particularly in public safety applications. They want to host the data. They don't want to take a SaaS service. And developer tools are really essential to the whole process because we're a content source that needs to be integrated into lots of different types of workflows. So we have basically the GlobeSpotter API, and then some administration tools that allows people to manage. In some cases, we have thousands of users that have subscriptions to this product, and our customers manage those people. Okay, I'm going to try. Okay. So Art, I'm just going to let you do the slide advancing. So this is our patented system. I think some of the key components of this. I think everyone, when you try to do mobile mapping, you're tying in the same sorts of the GPS and IMUs or motion sensors of different types. We also tie things into the wheels in case we lose GPS a lock, and particularly in urban canyons or dense tree canopy, something that affects signal so that we can still keep counting. And we've integrated in this particular version, this is the 9th generation of our camera system. It's basically one forward-looking panoramic camera and one backward-looking panoramic camera with with about 5% overlap on either side. All right, thank you. And the principle is basically triangulation through multiple panoramic views. And so when you sort of use the software and you click on a light pole, or you measure a point, or you draw a line, or you measure an area, you're basically signaling to our system to go and look at the different capture points. We collect it every 15 feet, or about 5 meters. So the camera's going along every 5 meters, snapping, snapping, snapping. And the end result is when you're using the product, it's giving you this precision really based on sort of triangulating from multiple vantage points. And because the panoramic data is basically, sort of spatially aware, even though it's really just, dumb pixels or RGB values to a computer, we actually know how to reproject, within the panoramic data, other data. In this case, this slide is showing you some examples of some two-dimensional and three-dimensional data overlaid. GIS layers, for example. Typically, GIS layers are 2D, so they'll lay down in a 2D realm. But ideally, if you have 3D layers, with Z values, as you can see in some of these bridge overpasses, you actually can draw in your real geometry, your vector data inside of our cycloramas, and go and start to do editing and maintenance or add new features that you see in the new data we collected. And I'll just briefly mention that our first U.S. customer is the District of Columbia in Washington, D.C. We signed a multi-year agreement with the Department of Transportation there. However, it is an enterprise license, so it isn't just the transportation group using it. It's going out into public works, in planning, into building permitting, and really throughout the city, and also counting trees, the whole sort of urban infrastructure. And the next few slides, I'll give you sort of some other use cases. For example, in property appraisal, this is actually a screen capture of an integration of one of our customers in Netherlands. So it's sort of tying the sort of the 2D cadastral maps with the attribute data of structures, and then getting the visuals from us from the cycloramas. And the next slide I'll show you goes into transportation. One particular interest that we've been involved with, or things that we've been working on extensively, not only from the R&D realm but also in real-world projects, is automated feature recognition, or in this case, signage recognition. This is a combination of using OCR technology to find characters and letters. Those are obviously not natural features, and so we can find those fairly consistently. And then from that, try to associate RGB values with it. So if we see sort of, something that the computer sees as the number 50, and then we associate it with sort of red pixels around it, and then we can, start to determine what type of sign it is. And so we've optimized this to, upwards into the 85 to 90% range in an automated realm. And then from that, we basically are delivering sort of inventory databases to customers, as the product, and they take the imagery sort of as a secondary reference from that. And then the next slide is talking about our base level system is a panoramic image that's about 11 megapixels, 2400 by 4800 pixels. But we often have use cases where we need to see higher resolution. And in our current system, we actually augment with additional cameras. In this case, for property assessment, we have additional cameras that you can sort of pan over in the cyclorama and then see into more greater detail. Next slide. The same thing for pavement management. This slide is illustrating that. We had put some forward-looking cameras in addition to the panoramic cameras, and we can get higher level detail. Of course, the goal ultimately is to tie machine learning to this, to do things automatically. All right, this is actually this is a screen capture of our Globe Spotter software, in the Netherlands, showing the Port of Rotterdam, because we have integrated multiple sources of data together. And what you're seeing in this illustration is obviously an oblique on the left. In the right side, the upper picture is taken from a car, and then the lower picture is taken from a boat. So sort of multimodal data collection from us is very essential. And tying in, particularly the ability to measure in all three of these environments, is really key. Next slide, please. And then from here, this is sort of just showing two different, terrestrial level solutions. He's integrating in the obliques from a partner of ours, along with our cycloramas, and I think you can start to see the practical uses for this type of product. Also, kind of try to wrap up. Very importantly, resolution is key, and in this illustration shows the next gen, the DCR10 digital camera recorder number 10 is going into 100 megapixels, and at this realm, we basically do away with the need to have inserts or additional sort of secondary cameras. And on the 3D reconstruction, also very essential. I mean, I think you'll see some slides, doing it from the air with oblique and aerial. But sort of what the missing component is in the urban landscape on the street, and that's where we're putting a lot of effort. And this you see going from a point cloud, which is basically stereo panoramic data. There's no LiDAR used in this technique. It's basically capturing every 2.5 meters of a panoramic image and using the stereo overlap amongst them to go from point cloud to colored mesh and ultimately to a textured mesh that looks realistic. And this is a combination of all of these products together. This just shows the oblique view. This is basically a technique of using sort of ortho and oblique to render a top-level view. And then if this were to move down in along the street, you would see it swap in to the higher level along the street. All right, next slide. I think that might be, I'm near the end, I know that. Yes, so this is the last slide. This is for anyone in the audience who's kind of curious about, well, where do we have data? In the United States, last year we embarked upon really sort of a marketing campaign to capture sample data. We called it the Driving Dutchman Tour. We took one of our Dutch drivers who'd never been in the United States and put him in, set him up in one of our systems in Jacksonville, Florida, and he went from Jacksonville all the way around up into Seattle, and spent from May to September of last year basically doing this tour, doing small vignettes or sample data sets of about 50, 55, maybe up to 60 different places. And all this data is available, for free online. And obviously we're building and growing the business this way. All right, very good. Well, I think that concludes my portion of the presentation. So, Art, I'd like to turn it back over to you.
All right. Thank you very much, Paul. I know it is so tough to get a lot of this information out in just 10 minutes. I wrote a column about your technology several months ago, so people may want to refer back to the column I did on Cyclomedia. Our next speaker is Dr. Pete Vanberg, and he's going to show you technology related to his new system called Stalker. And with that, I'll just turn it over to Pete.
Thank you, Art. Good afternoon, everyone. It's a great opportunity here to talk about some new technology. We've got a platform developed by Innovative Flight Solutions, and it's called the Stalker, and it's a multi-purpose tactical vehicle. It is capable of driving along land or as a parafoil operating by air. The genesis of this particular vehicle came from the owner of Innovative Flight Solutions, Robert Nolan, who back in 1979 was living over in Nicaragua with some Mosquito Indians when the Nicaraguan government flipped and went over to a communist-controlled organization, with no means to escape from let me just get back here. With no means to escape from Nicaragua, he ended up his family was captured, and his father and elder brother were killed. So he started to go to work on trying to figure out a ruggedized type vehicle that would have helped his family escape Nicaragua and get over to Honduras. And the Stalker is what has resulted here after a number of years of design and testing and so forth. It's essentially a powered parafoil that he has built and developed since 2003, and put in a number of different characteristics to it here to apply to intelligence, surveillance, and reconnaissance operations, search and rescue, border patrol. Use it as a video downlink, oil pipeline inspection, forestry service, spotting for forest fires, that type of thing, or other types of disaster assessment and relief. What I'd like to do instead of listening to me talk is I'm going to go ahead and push you a video. And the video clip, it's going to take a little bit to load in, and it's a little blurry at the start, but it'll get clear. But if it's about a 6-minute video, and this will explain more about the Stalker. If you have a trouble viewing the video, please use the YouTube link that's on the left side of your screen. Thanks. Well, thanks you all for taking the time to watch the video clip on the Stalker. Just a couple of things here as a recap. You can see that it's a pretty stable platform that's got a lot of opportunity here to mount different types of things and carry payload as well as personnel. It is FAA certified for day and night operations, and they have configured this thing and have plans to configure it as a remotely piloted vehicle or unmanned aerial system. Some of the air performance characteristics: it does fly up to 51 miles an hour and can travel 204 miles with a ceiling of 18,000 feet. Very short takeoff distance, 225 feet, landing distance 150 feet, and on the ground it can go as fast as 70 miles an hour. It does have a turning speed limitation on it, because obviously with that big fan in the back, you've got to give yourself a kind of wide berth. And then stopping distance 32 feet. The value of the Stalker is its low acquisition, maintenance, and operational costs. They've trained people to use the Stalker in as little as 12 hours and have full proficiency on it. The FAA seems to like the vehicle because it's under parachute, so even if it loses its engine, it can glide to the ground. And it's got a opportunity to do a myriad of operational missions. Thanks again for the opportunity to display this capability and this platform here. And I will pass it back to Art, who will move us into, I believe, a Q&A portion of the event. Thank you.
Yeah, thank you very much, Pete. I hope everyone was able to see those videos correctly. We now are going into the question and answer session. By the way, here is for those of you that want to have further contact with our speakers. Here are their emails. You can send them an email if you have further questions if we don't cover them in this session. So with that, I'm going to cover some of the questions that have come in. One of the first ones, John, with regard to the Alta system, the balloons, the question is, how does the FAA view either floating balloons or tethered balloons compared to the restrictions that they have on UAVs?
Funny you should ask. We've been, according to we read the regulations, our balloon is too small to be controlled, but we wanted an official opinion from the FAA, which came in 2 days ago. We are not subject to UAV controls in tethered mode. And we're waiting for an opinion in drift mode. In drift mode without a propeller, we have to have 2 redundant systems to bring the balloon down and land, and we do. We have a balloon within a balloon, and the spill valves are very accurate to 1,000th of a second, so we can spill very small amounts of lift gas and create a gradual trajectory to bring the balloon down.
Okay. Second question on the balloon is the vulnerability of the balloon and exactly the anatomy of it, how it's built, how it's structured.
The balloons are basically latex, very cheap, just a grade above a party balloon, really. But they are made for us with a certain wide mouth. The anatomy is there is an outer balloon, we call it the cruise balloon or mother balloon. There's a baby balloon inside, we call it the descent balloon. Each one has its own plumbing, its own servos connected to the brain. There's a skull below the plumbing that has our own hardware in it and software. And we have state-of-the-art GPS IMU that takes all the jiggles out of our shots and gives us very, very accurate pointing. It also senses altitude because at the launch we zero a barometric pressure sensor, and we're very, very accurate on how high the balloon is. And the balloon can figure out how much to spill if it needs to come down a tad. So I hope that answers the question.
Okay. And Paul, there was a question with regard to generating point clouds from the obliques. I think you just briefly mentioned it, but if you could elaborate on that a little bit further.
Sure. Well, this technique has really taken off extensively over the last 3 or 4 years. I think, probably, obviously from the slide, we're very focused on first solving the problem on the terrestrial, on the land-based side, from the street, which is actually in some ways a bit more difficult than from up above. But the technique is still the same, basically. Basically using, sort of overlapping vantage points from multiple panoramic views and having the algorithms basically sort out that it's looking at the same place. And that way it can take the source material and, do stereo offset, basically the difference between RGB values to create, a disparity to create the mesh. And then, of course, you have to weed out and pick the right texture from the right oblique image or from any image to match onto the surface. So this work has been a lot's been going on, not only from oblique and aerial traditional sources, but obviously in UAVs. A number of companies have been pioneering it. One of my former employers, actually, C3 Technologies, was one of the early pioneers. Technology spun out of Saab Group, which is an aerospace manufacturer out of Sweden. And I'm happy to sort of give more details on that. My expertise is probably more on the terrestrial side, but certainly well familiar with the oblique aerial side.
Good. Pete, this is a question regarding the Stalker. How stable is that aircraft in any kind of weather conditions? I mean, we occasionally do see photographs where parachutists or the wing flyers get into trouble. How stable is Stalker?
So far in all the testing that's been going, that it's gone through, it has been a very, very stable platform. It's a large parachute, so it's not as small as a civilian parafoil. So it's a large size parachute, and of course, from a jumper standpoint, being a former high altitude, low opening special forces jumper myself here, we jump in all weather, and so far the Stalker, as it's gone through, I mean, they've flown this thing through rainstorms, through snowstorms, and all kinds of other conditions here that you would think might affect its flying characteristics and make it unstable, and it has not to this point. So it's been a very stable platform here for the thus far.
Good. Ted, there was a question. I'm going to shorten it a little bit, but somebody wanted to know if these UAVs could be useful to monitor power grids, transmission lines and all of that. In particular, he was concerned about the transmission lines between Canada and the U.S. and whether that would be a cost-effective solution to monitor these lines.
Absolutely. Folks are looking at that situation already, from the physical structure of the insulators, the cabling, the wiring, and the structure, as well as the fuel accumulation of the sharp rail and such that builds up around it that generates fire hazards in the remote aspects of the power grid. So absolutely. In fact, not only can you do the visual, you can also pick up spectral characteristics. We were just doing some work yesterday looking at the spectral characteristics of the cell phone network out here at Camp Roberts, for example. So not just the power grid, but anything that has a grid orientation. If you can get the right sensor at the right weight, you can hang it on a UAV. So it's really the point is the UAV isn't the magic sauce here. It's the sensor and the application of it and the analytic software. The UAV is just a skyhook holding it in the right place.
Okay. And then the last question, which we could spend a lot of time. There was a statement or question, and I'm going to read it verbatim. Future of autonomous systems, swarm intelligence, computational intelligence, neuromorphic platforms, and cognitive computing impact on the warfighter and the IC intelligence community. John or Ted, you want to take that one?
From my perspective, this is Ted. We're in the process of heading in that direction. All the things we've spoken of here are basic improvements in cognition, either in speed or in understanding, and they're all contributing to that larger picture. Certainly the warfighter will benefit from that. The intelligence community will benefit from that, and so will the first responders and the city planners and such. So if you look back at the point that I was making 90 years ago, this started by taking cameras and hanging them out of airplanes, and now we're doing a lot more. Imagine what we're going to have in 10 years. So yes, all of the comments that were made are being evolved in their own domain. Pulling them together, integrating them, making them operationally useful is, I think, the task that we all have here.
If I may add, Art, this is John.
Yes, please.
I think the warfighter question's a good one because the war has changed a lot. The war is now terrorism, and terrorism looks for crowds and hurts innocent people. And so I don't think we're going to see a lot of guys in black hats take the field like we did in the old days. I think the warfare has changed dramatically. I think that anything that can look down and georeference and give details on suspicious circumstance and transmit it in real time back to a command center is going to make for will be the front end of just what we need for surgical warfare. I mean, there are drone strikes that are pretty good, but the observation part now needs to really be worked out. And we have an exercise coming up. I'm not at liberty to talk about it, but we have an exercise coming up where lots of balloons as silent sentinels are sending lots of imagery to 1 million eyes on the internet who are basically crowdsourced civilian monitors, and each one's looking for a certain thing. You know, that would never have been possible before. And it would have never been required before because the bad guys all were quite easily identifiable. Well, now you need more perusal, more visual information, and if it's georeference, you can do surgical strikes.
Now, the next question kind of should get everybody nervous because years ago when I was still in the Navy, one of the presentations at the Navy War College dealt with micro-miniature devices and, in fact, insect-size UAVs. Have any of you seen or looking at literally insect-size UAVs and microbots?
Well, just personally, a member of the family was involved at Vanderbilt some time ago, developing insect-size ground crawlers that had a life of 20 minutes or something like that, and a small video to relay back. I don't know much more about it than that, but certainly piezoelectric actuation, smart alloys, shape memory alloys, and things like that all contribute to the motoring aspect at that level and that scale. Certainly it's coming.
I would add that we have been watching a technology. I'm having a little brain lapse here. I can't think of the name of this stuff, but it's actually a material that's been developed that's lighter than air. The material itself is lighter than air. So the lighter than air part intrigues us because if you do not need propulsion and energy to stay aloft, there's a great economy of scale. So for a little thing like that if the material platform was actually lighter than air, you wouldn't need a buoyancy device. So that's kind of science fiction, but the pieces are all out there.
Well, with that, we're at the close of our session here, and as I mentioned early, the NCIS program I think is going to be very interested in some of the technology you've shown, and then you've opened the door for some even more advanced systems. So with that, Bethany, do we need to provide any other information to the audience?
Yes, thanks, Art. We just want to thank the audience for attending today's webinar. The videos from today's presentation will be available for just a couple more minutes here in the links on the left-hand side of your console, but you can also find them on the GPS World YouTube channel. An on-demand recording from today's event will be emailed to you in 2 weeks and will be available on gpsworld.com/webinars and at geospatial-solutions.com/webinars. We have several great events coming up this summer. Please join us for our next event, GNSS Interference Detection and Mitigation for UAV Navigation, scheduled for Thursday, May 22nd at 1 p.m. Eastern Time, featuring Electronics CEO Michael B. Matthews and Navtech GPS Vice President Frank Boynton, along with several other speakers. Also, just today, we have open registration for our June 5th webinar, also at 1 p.m. Eastern Time, How Much Farther to the Promised Land? Purchase Decisions in the Evolving Landscape of GPS, Multi-GNSS, and Alternative PNT. It will be moderated by GPS World's own Alan Cameron, Group Publisher and former Editor-in-Chief, with more speakers to be announced soon. You can register for these events online now at gpsworld.com/webinars. We look forward to seeing you there.